that term on video. Okay, guys. Worksheet 15, section 2.6. We had a couple warm-ups first, but make sure you take out, well, we're going to actually do one off 17 together as a warm-up, so please have out 17. And then 14 is the notes, okay? The assignment, which you actually will have time to get to, I think, today. It's a short lesson. 14 is notes, 15 is assignment. All right, this is off 17B. Can anybody help me factor the top to start us off? Thank you. Which will then factor okay, and the denominator? So on the far right here is our fully factored, and what do we notice right away? Okay, just to review, the domain cannot equal -4 or -2. You always do the domain from the very original. And then we're going to say there's a hole at -2, yes? What are we going to do to find the rest of that ordered pair? Plug it back in, but where? After we reduce, though, right? Otherwise, we'll get it undefined. Okay, -2 times -2 plus 1 over -2 plus 4 would be -1 times -2 would be 2 over 2. Did I do that right, guys? So the hole is at 2, 1. Where is there a vertical asymptote? And only at -4, right? There was a hole at -2, not a vertical asymptote. Everybody's okay with that? And it has to be an equation, right? End behavior. I don't want it. Let's find the x-intercepts. Makes the top 0. 0 and -1. Okay. Y-intercept. I think the only y-intercept is going to be 0, 0, yes? Because if we go back and plug a y back in for all the x's, we get 0 over 8. And if it's a function, it can't cross the y-axis more than once, and 0, 0 was already there. Okay. Then we're down to the fun end behavior. Bottom heavy, top heavy, or equal weight? It's top heavy. So what do we have to do? We have to divide. And we're going to do long division. I actually think we could probably cheat and use the reduced one and use synthetic, but we're going to do long division because we should review this. That's on the quiz. All right, so we have x squared plus 6x plus 8 into, do we need any placeholders? Maybe a constant at the end? That would be the only thing, right? Okay, who can help me? X squared to become exactly x cubed. So if we distribute to all three of these terms, we get x cubed plus 6x squared plus 8x. But we have to remember that we're subtracting. So we subtract and get 0. We subtract here and get -3x squared. Subtract here and we get -6x. Did someone else get that? Okay. What do we need to multiply x squared by to become this? Just a -3. So we get -3x squared minus 18x when I'm distributing here. and minus 24. Okay. We actually get to throw away a remainder, so we could probably stop, but just because we don't on the quiz, I'm going to keep going. If we're changing signs and adding, we get 12x plus 24. Did someone else get that? So if we had to do this on a quiz as a just divide question, we would want to write the remainder as this. But for the purposes of graphing, what did we find out the end behavior approach is? Yes, we get to get rid of the remainder. So if I go back to this slide, it is top heavy, and the end behavior asymptote, remember I came up with a new acronym, is y equals, was it x minus 3, guys? I can't even remember that one. Okay, let's graph. Goes through 0, 0. It goes through -1, 0. It has a hole at -2, +1. It has an x equals vertical asymptote at -4. It is approaching the end behavior of x minus 3, which would be crossing at -3 and going up 1 and over 1. Something like that. I'm thinking that there's clearly a chunk here. What do you think? Does anybody get it graphed on their calculator already? Which means there's probably a chunk down here that we maybe have to change our window to find. And I could be totally wrong, so let's hope I'm not, but I'm just going to type the original equation in. Michael, was that your paper I put on your desk? Okay. Since this class is so awesome and everybody turned one in, I could use process of elimination to determine the no-name paper. Is that looking like anybody's? Okay, what are we missing though? Something, yeah. So I don't know if I can just change the y. So I want to be on the other side of -4, so I'm going to try trace -5, and it's down at -20. It does get up as high as like -14 or something, but it's down there somewhere. It's not going to fit on the graph paper at all, no. Everybody okay? I just wanted to do one that had both a hole and a weird end behavior. And long division, yes. All right. My other warm-up for today is this question. I promised you one. You can write this down or you can take a picture when we're done here, but I promised you one like would be on the test. This says find all exact zeros, okay? So I will tell you the first thing I did was I graphed it on the calculator, and this is the picture that I got, okay? Then I tried, it looked like -2 or +2, so it did work. Does it seem okay? Then I tried -1, and that was also a 0. But then I did calculate the 0, and look this mess out here. That's supposed to be 0, right? But it says there's a 0 at some gobbledygook. So I had two nice ones though, so what could I do? I thought I heard someone. Synthetic division, okay? me see if I just go will these all go back to being tiny over there? Yay. Okay. Does anybody remember what the two were that worked? One of them was 2, 3, -3, -39, +33, and 66. Okay. Bring down, multiply would be add. Multiply, add, multiply, add, multiply. Okay. The other one that worked was -1. Bring down, multiply, add, multiply, add, multiply, add. If those didn't come out zeros, we did something wrong, right? If they worked when we graphed it. All right, it wants all of the zeros and factored form. What does this mean right here? Okay, so if we set that equal to 0, we could factor out what? A 3 first. If we set that equal to 0, we get x squared equals 11, so x equals, which I'm guessing is this 3.316, a ugly number over here. It doesn't equal 0, but you're right. When we go to write factored form, we can't lose that 3. All right, but as far as the zeros, we found the zeros to be 2, -1, square root of 11, and negative square root of 11. There should be 4, yes? Okay. And then factored form, can anybody help me with that one? Someone said 3 right away because we had to have a leading coefficient, right? X minus 2 plus 1. I don't care. You could leave it x squared minus 11 because it doesn't really factor, or you could leave it, it says on the quiz you can leave it either as linear factors, which would be x plus or minus square root of 11, or you can leave it in irreducible quadratics, which would be x squared minus 11. Either one is okay with me. All right, good? Oh, yeah, this is, yes, you can write it as this or this, guys. One or the other here. It's not like a big giant division problem or something crazy. Good question. So that would be something you could practice because there's one on the quiz that has some irrational roots, okay? All right, today's lesson is polynomial inequalities. Section 2.6 is all about inequalities. It actually lumps together everything except, well, it does quadratics. It doesn't do linear, okay? It does quadratics, polynomials. I think it originally had some absolute values in it, I'm not sure, and rational. We decided to split it into 2 days just to make it a little bit easier. The first day we're just going to do polynomials, which will include quadratics, okay? Real quick, if you had this question about this function over here, this is f of x, okay? It's a degree what? Degree 5? Does that look right? Would be a degree 5 equation because it has 1, 2, 3, 4 turning points and a bounce over here. Okay, if what the bounce is trying to show you is that sometimes at a 0, the graph does not change sign. Do you see here it was positive, then it became negative, then it went positive, then it became negative, but actually at this 0, it stayed negative. Everybody okay? Because of the bounce. So if we were doing an inequality and we're comparing f of x to 0, it's less than 0 between -4 and -2, between 2 and 5, and again beyond 5. Why can I not include 5? Because it didn't have the or equal to, right? If we included or equal to, then I could just say right up to -2, including -2, and over here I could say everything from here to the right, so 2 to infinity, because at 5 it hit and was equal to. Okay, here we had to use all soft, right? All soft parentheses because it didn't say or equal to. All right, and then if we had to say where it's greater than 0, we'd have to say to the left of -4, between -2 and +2, and that's it. All right, if we were saying greater than or equal to, this is weird. We'd have to include that value at 5. I've actually seen them just write 5. It's not an ordered pair. It's saying you need to include the 0.5, but that's just weird. I've seen them just write it with 1, 5 because it's just that number you're including. It's not an interval. All right, so what are we going to have to do? Well, we're going to take an equation like this. This one we wanted to move the 3 over so we could compare it to 0. That became 18. They factored and had zeros at -3 and +6. We're going to be asked to use what's called a sign chart, which it looks like this. You put -3 and 6 on a little number line in the right order, okay? If you have like 4 zeros, like -2, -5, 1/2, and -3.5, you got to put them in the right order, left to right, like a number line. Sometimes students struggle with that. Does everybody know what I'm talking about? Like, okay, don't do anything crazy. Then, if you want a graph, you could picture the graph or look at the graph on your calculator and see that the values are below the x-axis in between these right here. Otherwise, you can go to your table. What they did is they looked at the value at -4 and it was positive. They looked at the value at 0 and it was negative. And they looked at the value at 10 and it was positive. All right. It can only change value at the zeros, which are going to be called the critical points, because later when we talk about rational functions, it can change value when the top is 0 or the bottom is 0 because it has undefined places. So we're just going to call those critical points. Now this particular question said, where is it greater than 0? So it was greater than 0 this way and this way. And we're writing in terms of x. So we say below -3 and above 6. Now it said only greater than, so we didn't have to worry about square brackets or anything. All right. This is a really painful example they give us, that there can be no solution. X² plus 2x plus 2, if you graph it, it never falls below the x-axis. So it's possible you'll have a no solution problem. All right. Do you have this question? Okay. I want to talk about this one real fast. I graphed this on my calculator and did all kinds of fun here so that we could go through it quickly. Can you see what I did? It had a 0 where? At 3. It had a 0 at -1. It also had a 0 -2/3, which would be on which side of -1? 0 would be up here, -2/3, right? And, oh, I tested this. It's not a 0. Let me explain why I tested that value. What you want to do next, let me move this over just a little bit. What you want to do next is see, is it positive or negative between each of these? Okay. I didn't show a table, but can anybody tell what it's doing on the far, far left part of the graph? It's negative, yes? All right, in between here and here was questionable. What did it do? Was it bouncing? Was it going above? So I chose negative 0.8 to test. That's what this is about. Because this is negative 1 and this is negative 0.6 repeating, negative 0.8 fell in between there. Is everybody okay? So then when I tested it, I got a positive value in here. And then could you tell what it's doing in here between there? Yeah, it's below the x-axis. And then at 3 and to the right, it's above the x-axis. So the question says, where is it less than or equal to 0? It's negative here, and it's negative here. But because it says less than or equal to, I want to do what? I need square brackets here, here, and here. So I would write negative infinity to negative 1, and, whoa, negative 2/3 to 3. All right? Let's try, which is what we got. We did it right. We're good. Okay. Let's try this one on our homework. Does this factor? Doesn't factor, does it? No. Does that make anybody want to cry a little bit? Okay, so what do we have to do to find the zeros? Yeah, I think we need exact answers. So let's real quick go through quadratic. Opposite of b plus or minus square root of b squared would be what? 9 minus 4 times 1 times negative 2. What does that become, guys? Plus 8, right? All over 2a, which is 2. So I have 3 plus the square root of 17. Anybody getting that? And minus 3 minus the square root of 17 over 2 would be to the left of 3 plus, yes? Everybody okay? Is this a negative number or a positive number? I think it's negative. Somebody could just graph the whole thing, but square root of 17 has to be more than 4, right? So this has got to be negative. And this is a positive number. So if this is a negative number and this is a positive number, what falls in between them? 0. So could we plug 0 in to see what it was doing there if you weren't sure? Some of you should be pretty sure what it's doing. If these are the zeros, what shape is this? It's a parabola that opens. So doesn't it have to be doing that if those are the zeros? Okay. But if you plug a 0 in, you get 0 squared minus 3 times 0 minus 2, which is negative 2. Is that less than 0? Yes. So it's working in here. Do we need, you could check values out here, but it's above the graph, so they're positive. Do we need to include the endpoints this time? It was a less than only, right? Not a less than or equal to, so what do we want to do? Just soft parentheses. So our answer in interval notation is a nice disgusting maybe the good news is I put that on here instead of on your homework. I don't know, but it's much nicer when they factor. But that was good for our souls to do a little review of quadratic, right? All right. Number 2, does this factor? But what does that mean about the graph? Okay. What do you know about this 0 or this graph or this parabola, or there's a 0 at -1, and if we were to graph it, it's doing this, yes? Okay. How do we say this? Is it greater than 0? If it was or equal to, it would say the whole darn thing. But we can't say -1 because it's not greater than 0 at -1. It's equal to. So it is positive over here, and it is positive over here, but it equals 0 here, so we can't include that because of the greater than only. So we need to say to the left of -1. How do we say that? Not including. Okay, so this means all except -1. All right. This is the graph. I moved it over. X cubed plus 6x squared plus 5x minus 12 is greater than 0. Can you guys type that in and graph it? I just did it so that I didn't have to take time. I want you to get used to a sign chart because it's going to make a difference tomorrow. There are 3 zeros. Are they nice? I'll type and check them real fast. Oh, -3, -4? Okay. -4, -3, and +1 are zeros. Now, some of you can just look at the graph, but if you've typed it in, can you go to the table? What are you getting at -5? You look at the table. Okay, it is a negative value. Now, you'd have to maybe look at the graph to test in here, or change your table to count by 0.5s, or do an ask auto for your table. But can you go to back to the graph and type in -3.5 for me? Anybody typing in on the graph a -3.5? 1.1, so it's positive, yes? Okay. And then between -3 and 1, it is negative. If you go to the table, you should be able to check that as well. And then after 1, it's positive again. Okay. You can see that from the graph, but you can clearly check values from the table. It's going to become very important that we can check values on the table when we're doing rational functions, because the graphs are a hot mess. All right. This asks where it's greater than 0, because remember we changed it to say greater than 0. So where is it greater than 0? Between -4 and -3. Why am I not using square brackets? Doesn't say or equal to, okay? Together with 1 to infinity. This seemed pretty easy so far. All right, so last example, I think, isn't it? Yep. Number 4, what do we want to do first? Yeah, 3x squared plus x minus 2 is less than 0. Just way easier if we compare it to 0. Does this one factor? 2 and 1, let's see, we need a +3 and a -2. Does that work? So what are our critical values? -1 and positive 2/3. What's a value clearly in between there that I could test real fast? 0 is in there. If I go back to this one and I put a 0 in, I get -2 is less than 0. Is that true? Yes. The value we're getting is negative, right? Out here, if we test a value, it's positive. Out here, it's positive. Okay, are we wanting where it's positive or negative? We want values less than 0, so we want negative. Again, it's not or equal to. We could change it to or equal to just so we did another one, but it doesn't have an or equal to, so it's just -1 to 2/3. It looks like an ordered pair. We'd only know it's an interval by looking at the question. Everybody okay? Any questions? All right. So the homework is just to do 1 through 5 on 15A. The other 6 through 10 we'll do tomorrow after we've talked more about rational functions. I pulled open worksheet 12. Did anybody work on worksheet 12 like a good camper this weekend and have a question? Remember, you're supposed to do all the odds? No questions? Which two haven't you done? Let's do it. Okay, 37 and 39 are odds that Isaac didn't get to, so let's help him out. Does the top factor? Because he did his homework. Does this factor? I'm wondering if it has a whole. Actually, I think it does. Does that work? This would be positive 10 minus 3 would be 7 in the middle. So what's happening? There's a whole at -5/3. The domain would be x cannot equal -5/3. I heard there's no vertical asymptote. Is that true? Because there's only a whole. There's no vertical asymptote. So our end behavior equation is going to be really easy. We don't have to go back and do division because what is this going to be left? Yes. The end behavior asymptote is y equals 2x minus 1. And that's all the graph looks like, except it would have a whole at, we didn't finish yet. We got to plug in -5/3 right there. I'm getting -13/3. Okay. Have we got this on worksheet 12? Oh, what's happening on 39? How does the top factor? But then what? Yes, this one actually factors again. X plus 1 and x minus 1. Okay. What about the bottom? There is a whole. If we were doing the domain, just as a reminder, x cannot be 0 or 1. The whole is where? Okay, at 1, and then we could actually divide that out. When we put a 1 back in, we get 1 squared plus 1 times 1 plus 1 all over 1. That's 2. That's 2. So we get 4 over 1. Okay. Is there a vertical asymptote? Yes, at x equals 0. Okay, and the end behavior asymptote? Yeah, it's we have two choices. We can go back here and do long division, or we could divide here, but what do we have to do to the top before we can divide? Yeah, we'd have to put that back together. Well, actually, we won't even need to do synthetic. If we multiply this back together, we'll get x cubed plus an x squared plus an x plus a 1. And it's all over x. So if we divide an x out, we'll get plus 1. And the last would be 1 over x, which would be our remainder, yes? If we divide each of those. So the end behavior is x squared plus x plus 1. In other words, this looks like a parabola. Isaac's done with worksheet 12. Did anyone else work on it and have a question? Nice. No one else has a question? All right. So remember, these are the 5 questions you need to be working on. I'm not even on the right slides. I'm never going to find it. Right here.